In this lecture I'm going to solve the previous gate questions, right? So maybe 4 or 5 questions I will do. The remaining you try to do on your own, right? If you are not getting, please post a comment. So this question came in gate 2014. The value of the integral minus infinity to infinity sec square phi t dt is. The moment you see any square term, so always you try to apply the partial relation. Parseval's relation. So what is the Parseval relation? Minus infinity to infinity mod of x of t whole square dt is equal to 1 by 2 pi integration minus infinity to infinity mod of x of j omega whole square d omega. Right? So because we cannot, so it's very difficult to integrate sec square theta etc. So that's why we'll use the frequency domain. Now if I compare these two, so x of t will become sec 5t, because sec square means some x of t whole square, so x of t will become sec 5t. Now we have to expand this one. Sec theta is equal to sin pi theta, so sin pi into 5t by pi into 5t. So this will become sin 5 pi t by pi t into 1 by 5. So if you see this one, this is looking like this, sin wt by pi t, and this is 1 by 5. Now what is w here? So in time domain, if there is a sine term, so sin wt by pi t, in omega domain we know that there is a rectangular function. This w will be here. So what is w here? Minus w to w, but w here is 5 pi. So here minus 5 pi, we will get 5 pi here. This is omega. Now actually if there is no 1 by 5 here, so your magnitude is 1, but here 1 by 5 is there, so this is the magnitude. So this is the x of j omega, right? Now we are using the partial relation, and we are using the rectangular function. So if it is in omega domain, so we'll get sin wt by pi t in the time domain. So and amplitude is 1 by 5. Now it's very simple to integrate this function x of j omega. So I write here. Now the partial relation, this 1 by 2 pi minus infinity to infinity, now it will become only minus 5 pi to 5 pi. What is the amplitude? 1 by 5 whole square d omega. Now 1 by 5 square means 25, so this is 50 pi, and only will get omega because this is constant. So omega means 5 pi minus of minus 5 pi. Simply we will get 10 pi. So pi cancel, 0 cancel. So what are this value? Simply 1 by 5. A very simple question. So this is 1 by 5. So that's I told you in the beginning of this, when we discussed about the sinc function and rectangular functions, we will get frequently questions from this sinc function or this rectangular functions, right? Next we'll do this question. This is came in gate 2012. The Fourier transform of a signal h of t is h of j omega is equal to 2 cos omega into sin 2 omega by omega. The value of h of 0 is, again see this sin 2 omega by omega, so we'll get a rectangular function in the time domain. So first we need to find the inverse Fourier transform. So this is h of j, right? So first we'll take h of j omega as like this. This 2 I will make 2 by omega sin 2 omega, and cos omega is separate I will do. Now if I expand this one by Euler's relation, so it will become e power j omega plus e power minus j omega by 2 into 2 by omega sin 2 omega, right? So again, so if I multiply, so what I will get? 1 by 2 e power j omega into 2 by omega sin 2 omega plus 1 by 2 e power minus j omega into 2 by omega sin 2 omega. Now why I kept this cos omega, these terms like this is, there is a reason. Now whenever there is a e power j omega into, this is a constant one, here also constant one, that is in time domain. If it is in frequency domain, it is e power j omega t naught. So it is a time shifting in the time domain, right? So once we know what is the inverse Fourier transform of this one, then we can easily shift that signal. Similarly here also, and the amplitude will be simply multiplied. So what I have to take here is, so I'll take like this. So what is the 2 by omega sine 2 omega inverse Fourier transform? Now we know that if there is a time domain signal I am taking minus t1 to t1, what is the Fourier transform? It is 2 by omega sine omega into t1 we will get. Now if we compare these two, so 2 by omega matching, omega matching, in place of t1 we are getting 2. So what is the Fourier transform of this signal? Simply inverse Fourier transform. Minus 2 in place of t1 we got 2, so minus 2 to 2, and amplitude is 1. So this is the time domain signal, right? So we got, so we'll take like this, 2 by omega sine 2 omega. So inverse Fourier transform is, we got minus 2 to 2 t and 1 amplitude. But we don't require this one, we need to multiply with some functions. So what we'll do is, so first I will make e power j omega 2 by omega sine 2 omega. So what is the inverse Fourier transform of this one is, say this is a time shifting, so I'll make here, if x of t plus t naught is there, so what is the Fourier transform? E power j omega t naught into x of j omega. Yes or no? So we already got this one too for this one. So for e power j omega, suppose if I assume this is some x of t, so what we should get? X of t plus t naught. In this case t naught is 1, so what is this? We'll get t plus 1, right? Then we have to multiply with 1 by 2. So what is the amplitude we'll get? Simply 1 by 2, right? So just take it as like this. Similarly minus, no, not minus, plus only, 1 by 2 e power minus j omega 2 by omega sine 2 omega. So what is the inverse Fourier transform? Again we will get 1 by 2 x of, so now you are getting minus, so simply x of t minus 1. So this is x of t. So but we need summation of these two signals. So one time we will shift right side, one time we will shift left side, then we can add simply. So what I am doing is now shifting the signal. So x of t plus 1. So see here, minus 2 plus 2. So it is left shift by 1. So it will become minus 3 to 0 and 1. See, 2 minus 1, 1, 0 minus 1, minus 1, minus 2 minus 1, minus 3. Right? So what is the amplitude? So it should be multiplied with 1 by 2. So this is also 1 by 2. Plus, one more is, so it is right side shifting. So what we'll get? Minus 2 to plus 1 if we add, minus 1 to 3, right? So this is the t, this is the t, and amplitude is 1 by 2. And what is the signal? 1 by 2 x of t minus 1. If I add these two, what we will get? See, if you see this, minus 3 to minus 1, this is the 1 by 2 only. But after minus 1, it is adding 1 by 2. So the resultant will be minus 3 to minus 1, we will get 1 by 2. But minus 1 to 1, see here, here also minus 1 to 1, 1 by 2, minus 1 to 1, 1 by 2. So 1 by 2 plus 1 by 2, we will get 1. So minus 1 to 1, we will get 1. Then again after 1, so here we are getting 0, and here we are getting 1 by 2. So again it will be 1 by 2 from 1 to 3. So this is the final answer, x of. So we need to find h of t. So this is the inverse Fourier transform for the given signal. But he asked what is h of 0 value. So what is h of 0? At 0 this amplitude is 1. So at h of 0 what is amplitude? Simply 1. So it is 1. So we need to apply the this is a sinc function or sampling function. So rectangular function we get in the time domain, as well as the time shifting property we need to apply. Then we have to add the two basic sequence, and we need to find the 0 at 0 what is the value. So this is how to do this problem, right? So in the exam, so this is I explain very step by step, but we don't require this step by step. So directly you can apply these steps, right? Because we know what is the 2 by omega sine 2 omega this, and if I directly add 1 by 2 e power j omega, I'll get this, and etc. So by looking this signal, we can easily tell the answer, right? So that is about this question. Next we will see one more question. This is game in gate 2008. X of t is equal to 1 from -1 to 1, 0 otherwise. Two of the angular frequencies at which its Fourier transform becomes 0. So we need to find the frequencies at which this Fourier transform of this signal will become 0. So again, see, if it is very simple. So -1 to 1, it's a 1. There is a rectangular function, right? So that we know already, just now we have discussed. This is -1 to 1, 1. This is x of t is given, right? What is the Fourier transform of this one? 2 by omega sine omega into t1. What is t1? It's nothing but 1 only. So this is a Fourier transform. But what we need to find? Two angular frequencies we need to find. So where the x of j omega will become 0. So we need to equate with 0. So 0 means we need to what is the value of this sine when it becomes 0? Sine n pi. So anyway, 2 by omega is going that way, so it will become 0 anyway. So sine omega is equal to sine n pi. So what is omega? Simply n pi. But he asks you two angular frequencies. So if n is equal to 1, n is equal to 2, n is equal to 3, etc., plus or minus, right? So but in the answer he given only plus values. So if n is equal to 1, pi, n is equal to 2, 2 pi. So what is the answer? Okay. So no 0.5s, etc., right? Only pi and 2 pi. Now you may think that you may get a 0 also, but it is not the condition, because n cannot be 0. If n is 0, nothing is there, right? So n is non-zero integer always. Remember this point, right? Now we will solve this question. So this question came in gate 2005. For a signal x of t, the Fourier transform is x of f. Then the inverse Fourier transform of x of 3f plus 2. So we need to find the inverse Fourier transform, this 3f plus 2. Now by looking this question, so we need to find the x of 3f plus 2 inverse Fourier transform we need to find. Now if you see, this is frequency scaling as well as frequency shifting is there, right? So we need to apply two properties in the Fourier transform. Now what are those two properties? Before that, whenever there is a scaling as well as a shifting, always you try to take common, that is 3. If I take common, it will become f plus 2 by 3, right? Now then what is the first step we need to do? Either we need to do the shifting first, or we need to do the scaling first. When you are taking the common, this scaling, always you do the first step is scaling, that is 3f. Then the second one is the shifting property, so that is x of 3 into f plus 2 by 3. I hope you got what my intention. So when you take the common, that is 3, then first we will do the scaling, then shifting, right? Otherwise if you do f plus 2 first then scaling, so we may get the right answer also, right? But always this process is very good when you solve the problem in the frequency domain, right? So you try in the opposite way, that is first to do the shifting, then scaling. So is the answer is right or wrong, or matching or not, just check. Now what is the way we need to do? Now we know if x of t is there, and this is the Fourier transform is x of f. Now I'm doing the in f domain. Now to scale in the frequency domain, what we need to do? We need to scale in the time domain. Now if you see this 3f, so I need 3f. So what is the scaling factor? So it should be t by 3. Then only we'll get f by 1 by 3. So I will get 3f. but this is 80. 80 is 1, a is 1 by 3, so 1 by a mod a, that is 1 by 3 into x of f by 1 by 3, so it will become x of 3f, the first one, right? But we need only x of f, so x of 3f, so this 1 by 1 by 3 going that side, that we will see anyway later. So this x of t by 3, what is the Fourier transform? 3 into x of 3f. We need to apply the frequency shifting property. So when we want frequency shifting, we need to multiply with the e power j omega naught t in the time domain. Now if I multiply with, suppose, e power j omega naught t, but here we are getting them in frequency domain, right? So what is omega naught? Omega naught is equal to 2 pi f naught, yes or no? 2 pi f naught. So what is f naught we require? That is important here. So this is the f naught we need require. So what is f naught? So f naught is equal to 2 by 3. So what is omega naught will become? Omega naught is equal to 2 pi into 2 by 3, so it will become 4 pi by 3. So in place of e power j omega naught, now what we will get? E power j 4 pi by 3 into t into x of t by 3. So what we will get? So only this 4 pi by 3, 2 pi is over, so 2 pi into 2 by 3. So what we will get? x3 into x of 3 into f plus. So see, we need plus. If there is a plus here, I will get minus here. So we need to add minus here, minus, right? So in the, when we discuss the Fourier properties in part 3, right? So whenever in the frequency time domain e power minus j is there, in the frequency domain you will get plus. Whenever it is plus, you will get minus here. So to get plus, I need minus here. So e power minus j 4 pi by 3 into t x of t by 3. So what will get? 3 plus f into 2 by 3, right? So this is the Fourier transform of this e power minus j 4 pi by 3 into t x of t by 3. But what is we required? We require only up to here. So from this, now we can easily get the x of 3 into f plus 2 by 3 inverse Fourier transform is what? So I don't require 3, so it will become 1 by 3 into e power minus j 4 pi by 3 into x of t by 3. So this is the Fourier transform, inverse Fourier transform of the given signal, which is x of 3f plus 2 by 3, or simply x of 3s plus 2. So this is how to do this question whenever there is some mixing property, that is shifting as well as scaling in the frequency domain, right? Next we will see in opposite. So in the next GATE 2016 given x of t is x of j omega, in omega domain is given. What is the Fourier transform? X of 5t minus 3, right? So it's very simple. Again we have to take 5 common, then it will become t minus 3 by 5. Now what is the first step? We need to do the scaling, right? Now what is the scaling? X of 80 means what? What is the Fourier transform? 1 by a, 1 by mod a, or just we can make 5 also, 1 by 5 x of j omega by 5. Next what we need to do? 5 of t minus 3 by 5. So what is the Fourier transform? We will get x of, suppose, t minus t naught. So what we will get? E power minus, if there is a minus we will get minus, but in the frequency domain if there is a minus here we will get plus here. So just keep it in mind that there is a e power minus j into omega into t naught. T naught is 3 by 5. So 3 by 5 by 5 x of j omega by 5, right? So we can easily write this one, e power minus j 3 omega by 5 by 5 x of j omega by 5. So this is the Fourier transform of x of 5t minus 3. So very simple. We need to apply again scaling as well as shifting property, right? Now we'll solve one more problem. So this question came in GATE 2008 for RCL. It is common question, right? Now we'll solve one more question which came in GATE 2018. Actually this question was linked answer question. That is, if I find a, then only we'll get correct answer for B, right? Now it's very simple question actually. H of t is given e for minus 2t u of t, so we need to find h of j omega, right? The Fourier transform h of t. Then if x of t is 2 cos t, what is the we need to find y of t, right? Now we'll solve one more question which came in GATE 2008. So actually it is came for 4 marks, like a linked questions, right? So once we find A, then we can find the B option. So h of t is given, that is e power minus 2t into u of t. We need to find the Fourier transform of h of t, and if x of t is given, that is 2 cos 2t, then find y of t. So actually it's very simple question. So to find option A, it's very simple actually. If you know the basic signal Fourier transform, that is e power minus at into ut. So what is the Fourier transform? Simply I can write h of omega or h of j omega. Simply 1 by a plus j omega. If a is 2 and this is j omega. Now, now to solve option B, so this LTI system response, impulse response is given and X input signal is given. We need to find the y of t. So if you recollect from the sinusoidal steady state analysis, whenever there is a system with a impulse response of h of j omega, and if I give some sinusoidal signals, it may be a cos omega t, right? So y of t will become a into m into cos omega t plus 1. This a is a here, but m and this magnitude and phase will be given by the system response, right? So from the given what we got, that is 1 by 2 plus j omega, we got h of j omega, and this is 2 cos 2t. So what is y of t? We need to find. Now if you see what is omega equal to 2 and what is a is equal to 2, right? So if I take h of j omega, which is 1 by 2 plus j omega, first we will find the magnitude of this function, which is mod of h of j omega at omega equal to 2. So this will become square root of 2 square plus omega square, and omega is equal to 2. So 1 by square root of 4 plus 4, because omega equal to 2. So what is this? 1 by 8. So we'll get 1 by 2 root 2. Right? 1 by 8 can be written as 4 into 2. So it will be 1 by 2 root 2. Similarly, phi is equal to angle of h of j omega. So 1 by tan inverse imaginary part by real part. If it is coming the up, we will get, so this is actually angle, no? So we'll get minus tan inverse omega by 2. What is omega? Omega equal to 2. So 2 by 2 means 1. Minus tan inverse 1. So minus 45 degree. That's it. Now it's very simple now. What is y of t? A is 2. So 2 into, and what is a? M we got 1 by 2 root 2. So 1 by 2 root 2 cos omega is what? 2t plus, what is pi we got? Minus 45. So it is minus 45. So 2 will be cancelled. So 1 by root 2 cos 2t minus 45 degree. Right? It's very simple if you know this concept. That is, whenever a system response is there, if I apply sinusoidal or cos, sine or cos, so we will get this a into m. So m will be given by the system response, and omega t plus pi. Pi is given again by the system response. So if you know the system response in frequency domain, so we can find magnitude as well as phase. Magnitude will be multiplied with in this magnitude, and the phase will be added here, right? As simple as that. Suppose, so in this problem there is no phase angle here. Suppose in maybe sometime if you get some a cos omega t plus or minus theta, so it may be minus, it may be plus. So in that case, what is the output you will get? So in that case, y of t is equal to, the magnitude is a into m, again m is given by the system response, into cos omega t plus or minus theta plus pi. So whatever it is there in the input, so we'll get same in the phase, right? Omega t plus or minus theta, omega t plus or minus theta. The extra phase will be given by the this frequency response of the system, right? So that is about this one. Next, in the next lecture, so we'll start the discrete time Fourier transform, right? Now I solved only 5 problems, maybe 6 problems at the previous gate. So you try to solve more previous gate problems. If you are getting any problems, so please post a comment below this lecture, right? And also we can discuss not only this Fourier transform from the previous gate. So I may be posting the problem sheet on this Fourier transform from the various textbooks, right? I will post a problem sheet in our blog, right? So maybe tomorrow, right? Then we can discuss those problems also, right?